Thank you so much for the introduction, and of course, many thanks to all of you guys for joining. I mean, I'm just impressed by this amazing crowd, to be honest. I've already met so many bright minds, and this was just awesome. And honestly, you know, that this makes me exciting. This makes me really excited, but also a little bit nervous at the same time. But nevertheless, I'm happy to be here, but I'm definitely more happy that you are here. So thank you so much for coming again. My name is Ingo Philipp. I'm on the product management team at Tricentis. Tricentis is a software company. We are located in Vienna, the beautiful capital of Austria, in the heart of Europe. And you might already have heard about one of our flagship products. It's called Tricentis Tosca. But don't panic in this session. I won't talk about our company and I won't talk about our products. I would like to establish a link in this session, a link between digital transformation and software testing. And in doing so, I'll just want to show you what are the principles, the methods, and the techniques we apply through software testing to support any kind of digital transformation initiatives. Now, that's the master plan, and I hope that works for you guys. Now, to get started, let me start with this picture here, guys. We are all riding the same wave, right? The tsunami of the big money that is now called digital transformation. And almost every year, the analysts out there remind us that digital transformation is all about creating new sources of customer value at an ever-increasing operational speed. Now, how do we do that? Well, we do that by exploiting digital technologies. Now, what is that? Well, that's any kind of technology that generates, stores, and processes data in terms of two states, 0 and 1. And that is software, ladies and gentlemen. So software definitely fuels the fear of digital disruption, I would say. And therefore, digital transformation is a software-led transformation. Now, that's good for us because somebody needs to test that software. But this begs the question, why do we need to ship our software product so fast? Well, guys, I think the reason for this is fairly simple. Because I believe that our business, that all of our business is about one single thing. It's about a value exchange. A value exchange between your company and your customers. Now, how do we play that game? Well, the first thing we do is we try to identify the needs of our customers. We try to identify their wants, their desires, or we try to uncover their problems. Now, once we did that, we move on and build a solution in our software to solve the problems of our customers. And we need to do that fast because the competition is just a single click away from us, right? And usually it takes a lot of those loopings. It takes a lot of experiments and so fails in order to get the problem solved because it's simply hard to solve that problem. But we need to solve the problem because our product is just a solution. It is just a solution to the problems of our customers. And if the problem isn't solved by our software, then the product simply doesn't work. Now, once we at least thought we solved the problem, we move on and ship our solution to our customers. So we provide value to our customers by solving their problems. And our customers then provide value back to us by paying for what we have built or by providing data, right? The new oil out there. Now, that is how we exchange values. And the goal is to accelerate this value exchange. Now, how do we do that from a development and testing perspective? Well, we do that by wrestling ourselves through the whole delivery process multiple times at ever-decreasing cycle times, where the customer sits at both ends to close the feedback loop as fast as possible. Now, how did software development and now software testing reacted on that need? Well, guys, in the past, which still is the future for most companies out there, the whole software delivery process was carried out in separated phases, phases which didn't know from each other until the previous one completed. And so we call these phases the walls of confusion. And so it's absolutely no surprise that when critical defects were detected in the later stages of that delivery process, this often caused the entire software product to be rethinked, to be redesigned, to be re-implemented, and to be retested. And so it took us simply ages to deliver our solution to the problems of our customers to our customers. And then a few years later, some guys from Rational came around and they introduced more incremental or iterative approaches to software development. Now, one of which was the rational unified process. So they just compressed everything down to 4 stages, gave fancy names for those stages, but they didn't really manage to solve the underlying issue, to compress the delivery pipeline. And so then around the turn of the millennium, also the large companies out there started to adopt agile delivery processes, such as Scrum, Kanban, less the scaled agile framework, or the Spotify model, for example. And this fundamentally changed the way how we deliver software. Because we've moved away from following rigid rules, and we've decided to evolve in flexible frameworks. And I think it's perfectly described by all the principles of the Agile Manifesto. But this wasn't the end of the story, right? These companies then quickly realized that product increments created by software development then often caused severe problems on the operations side. And then the blame game began, right? And this then gave rise to the DevOps movement around 2007 and 2008. And that is where we are right now, guys. We do that? Well, I think Darwin already knew it, right? It's not the strongest that survive, nor the most intelligent, but the one most responsive to change. So nowadays, it's no longer about mastering continuous improvement, it's about mastering continuous change. Since to overstate the case a bit, software these days is not written, it is rewritten. Now, guys, I've put a lot of drama now into that story, so now let's go back to reality and let's see how things are really working out on planet Earth these days. So when we talk to our partners, to our customers, or to analysts, we constantly see that picture on an average software development project. We see that most of the testing still goes into manual testing in terms of repetitive manual test case execution. And this not only includes the creation of those test cases, but also its execution and maintenance, and also the localization and preparation of test data during manual test execution. And just a small fraction goes into test automation, let's say between 10 and 20% or so, where most of the test automation is carried out on the level of UIs, the user interfaces. Less is done on the level of APIs. And aspects such as load testing or security testing, well, honestly, they are not really present these days. And so we see here 2 major challenges. The first one, that's the obvious one, right? It's manual testing. It's just the top technical challenge in any sort of app development. The second one is test automation itself. It is still regarded as a developer's discipline because it still asks for comprehensive programming or scripting skills, right? And so it becomes perfectly obvious that when you as a tester, as a manual tester, aren't able to get rid of this huge burden of repetitive manual test case execution, and when you aren't able to create and to maintain a test automation solution, you won't be able to survive and so to succeed in any fast-paced development environment. And therefore, we say that the future of companies that are in these situations needs to look like that. And here, just let me highlight 4 points, guys. The first one, again, it's obvious. We need to achieve automation rates that are far beyond 80% or 90% or even higher to even be able to keep the pace with agile development. Second one, we need to have a key enabler at hand to achieve those high automation rates. And that is what we call orchestrated service virtualization. Number 3, API testing. So we are convinced that the future of test automation must focus on APIs in order to scale your test execution to almost any arbitrary level. And the last point I want to highlight here is tightly connected to the first one. So due to the dramatic increase of test automation, of course, the effort in manual testing needs to decrease dramatically. But in doing so, we also say it needs to transform into exploratory testing. Now, that's in a nutshell how we see the future of testing at Tricentis. And now let me guide you through all of those points to also tell you why, guys. Can you still hear me? In the back? Is it on? Okay, move on. Okay, guys, now let me guide you through all of those points to also tell you why we see it in the way we see it. And let's start with API testing. So why the heck should we even care about that? Well, in order to figure that out, let's see how the degree of completion of UIs and APIs usually evolve over time. That means from the beginning of a certain sprint to its bloody ending, let's say. Now, when it comes to UIs, you will see a picture like that. So you will most probably start with a mock-up in order to figure out what your UI should look like, right? And then you start your UI implementation. But right after the first feedback gets into the game somewhere here, you most probably will rethink your UI proposal. And you most probably will redo your UI implementation. And this usually happens over and over and over again in the course of a certain iteration. And so you must be lucky, guys, really, really lucky to just complete your UI implementation at the end of a certain iteration. And here the question is, well, can you keep the pace with any agile development when you have a single-minded focus on UI test automation? Well, the answer is simple. No, you can't. Because in contrast to UIs, the APIs usually evolve like that. They're much earlier available in the development phase. And so this allows you to start your test automation endeavors much earlier. So it allows you to shift left your test automation. And in addition to that, the UIs, the API test automation, in contrast to UI test automation, is much easier to create and it's much easier to maintain. Why? Well, because the APIs are way more stable than the UIs. And API test automation, in contrast to UI test automation, is just damn faster than UI test automation. Now, API testing then lays the basis for what we call orchestrated service virtualization. So what the heck is that thing about? Well, guys, when we arrive at our customers, we usually see system landscapes that look like this. They look like disease gene networks, right? Huge sets of interrelated and interconnected external as well as internal systems and system components. Now, where are you? Well, you are right in the middle, and you need to take care about your system or your system component. But in doing so, you also need to communicate with all your surrounding systems in order to account for proper enterprise end-to-end testing. But what happens in reality? Well, in reality, most of the systems are either broken, they're under development, they're under maintenance, they're simply not accessible. And then you can just say, welcome to the tester cell, right? You are not able anymore to repeat your test execution without interruption. And so you need to have the ability to virtualize. That means to simulate the communication between your real system and one of your surrounding systems, for example. And we also generalize that idea in our testing projects. So we don't just simulate the communication between your real system and one of your surrounding systems. We also simulate the communication and the behavior between all simulated services. So what orchestrated service virtualization then provides to you are stable test environments. And this then eventually leads to a robust test automation. Now, guys, with all that, I just want to say that API testing and orchestrated service virtualization, so these are the two fundamental pillars of our test automation approach. And automation in general, as we all know, is just the dictate of today, right? It doesn't just make testing easier, it makes testing even possible in those fast now, fast now, fast now environments. But the question is that already the end of the story? Is test automation all we need, the silver bullet to solve all of our testing problems? Well, let's figure that out, guys. Let's figure that out by visiting London. And now just imagine you are a tourist, okay? And you want to visit London, and you just have 2 days' time to visit London. And you don't just want to be a tourist, you want to be a prepared tourist. So you want to see the right places at the right time. Now, for the sake of simplicity, let's first imagine you just want to visit those two sites in London, Site A and Site B. And that might be the Westminster Abbey and the Buckingham Palace, for example. Now, here the question is, in how many different ways can you visit those two sites? Well, it turns out that there are 5 ways to do that. The first one is the trivial case. You decide to not go to any of those places. The second one is you say, well, you just want to visit A. The third one is you just want to visit B. Number 4 is you go from A to B, and number 5 from B to A. So you basically have 5 different ways to visit those two sites. Now, guys, I want you to imagine that London now represents your software product. And every site in London represents a certain function or a certain feature in your software. And as we all know, London is a pretty big city, right? At least in the European standards. And so usually is your software product, right? There's a lot to see and there's a lot to execute, and so there's a lot to test. And on that picture, you now see 50 of those functions and features in your software. And what do you guess when you ask the same question as before? In how many different ways can you now walk through all of those functions and features? Well, it turns out to be a long, long way. It's about 100 billion combinations you need to account for. But now you might say, well, that's baseless, right? I usually don't have the need to test every function in every possible arrangement with all the other functions. And you are absolutely right. But you won't just have 50 functions you need to check or to test in your software. You will have thousands, hundreds of thousands, even millions or gazillions of those beasts you need to test. And so all I want to say here is that you will never be able to test everything as exhaustively as possible because of the time, the resource, and the budget constraints you're confronted with every single moment in your testing business. And so the only decision we have to make at the end of the day is how much risk left over are we willing to accept when we release our software product. And so risk-based testing on an enterprise scale becomes more and more important, guys. So the bottom line here is that testing harder in terms of more and more automation can't be the answer. Testing smarter is, right? So today I think we already heard that doing the things right in terms of doing them fast can't be the answer. It's about doing the right things right at the same time. Now here's the proof, guys. Now imagine that these dots here represent all the test cases in your regression test portfolio. And furthermore, imagine that all these test cases pass in the last regression test run before you decide to ship your software product into production. And then you most probably might conclude, well, that looks good, ship it. And that is what you then probably do. But just a second later, you will then realize something like this. You will realize that repetitive test case execution is by far not enough to see the iceberg coming, right? To avoid situations like that. So what are the things we need in order to avoid those scenarios? Well, to explore that, guys, let me start with this picture here. This is how I see software development, to be honest. You know, software development is a lot like wrestling in the mud with such a pig, right? And after a few hours, you realize the pig just likes it, right? And the pig is the software, yeah, to make that clear. Now, when software development is about wrestling with the pig, the question is, what the heck is then software testing, right? Well, then software testing, obviously, is all about washing that pig. And that can be messy, right? Because it has no rules, it has no clear beginning, no clear middle, and no clear end. And sometimes it's kind of a pain in the ass, right? Because when you're done, you're not even sure if the pig is really clean or why you were even washing the pig in the first place. So guys, now let's figure out how we wash that pig, how we test software, okay? And again, I need your imagination. So please now imagine that this rectangle, this wide rectangle here, represents your software. It represents the entire functional and non-functional spectrum of your software. So that's all there is, okay? And it's all you could possibly know about your software product. Now, this green rectangle represents all what you currently know about your software product. And this rectangle is apparently smaller than the previous one, because I'm at least convinced that you will never be able to always know everything about your software product down to the very last detail. Now, the red rectangle represents all what you repeatedly check in your software, for example, by test case automation. And again, this rectangle is smaller than the previous one, because as mentioned before, you will never have the chance to automate everything you know at any time because of the time, resource, and budget constraints you're confronted with. But here the question is, would it even make sense to automate, to codify all your knowledge? Well, I would say no, guys, Because if you would solely aim to codify, to automate all your knowledge, how on earth would you create new knowledge about your software? And you have to create new knowledge about your software because your software constantly expands, it increases, complexity increases, its richness and features increases. And so you constantly have to increase the knowledge about your software product in order to detect problems that are far outside your checking regime. And this is what testing, at least for me, is all about. Testing is all about closing this knowledge gap. It's all about closing the gap between what we know and what we don't know about our software. So the goal of testing is rather information than automation. And the reason for this is fairly simple. Ken Kana once explained it to me like this. He said, well, look at the test as a question you ask your software. And the point of running that test, I'm not talking about test cases, is to gain information about your software products, to uncover those risks, those problems that might happen. And so testing is, always has been, and always will be, guys, a search for information. So we search for that information about the risks, about the problems that might happen in our software. And we then enable others, through this information we provide, to make business decisions. For example, shipping decisions. So I regard testing as an information service to enable others, like product owners or product managers, to make business decisions. And I'm not degrading testing by saying that, to make that clear. Now, how can we do that? How can we collect information? Well, in case you want to see it black and white, you can do it in two ways. You can do it first by checking. Now, when you check something, you examine your software by applying algorithmic decision rules to specific observations of your product. So what the heck does that even mean? Well, this simply means that here you just try to find an answer to the question, does this assertion pass or fail? And that is what you usually do by test case execution, right? So that means you verify through specific instructions that are contained in your test cases. And in doing so, you only pay attention to the deviations of the expected results in your test cases. That means that checking is all about creating test cases. It's all about following specific procedures. And why do you do that? Well, to examine specific conditions in your requirements. For example, acceptance criteria in your user stories. And by reducing testing to checking, you make testing become a factory process. And what that means is you put requirements in and you get test cases out. Now, this says that any kind of checking you do is all about confirmatory testing. It is conservative confirmatory testing. And that's a very mechanical approach to testing, especially when it comes to test automation, right? Because automation is just doing what automation does. It just processes predefined data through your application in predefined test steps. That's all automation is doing. So it's all about monitoring your known risks. Here you just confirm what you already know. You confirm your existing beliefs. And in contrast to that, exploratory testing is all about analyzing potential risks. So here you should focus on things you don't know. You should focus on illusions you are holding true without any empirical evidence. And how do you do that? Well, by investigating your software product through powerful experiments. Now, how do you do that? Well, by applying several kinds of testing heuristics in your testing. And in doing so, you don't pay attention to the deviations of artifacts like test cases. You pay attention to test oracles. And the test oracles, as we all know, is nothing more than anything that helps you to define whether a test has passed or failed. And that might be a specification, that might be a design document, or that might be something you have discussed yesterday with your developer friends, for example. So it's rather about creating test ideas than creating test cases, guys. And when you do exploratory testing, you follow your clues in order to examine potential risks. And so the risks and the findings is what really guides your search in testing, guys. And this then eventually makes testing become an adaptive investigation rather than a factory process. And that is how you can really add value to the whole software delivery process. Now, don't get me wrong, guys. I'm not saying here that we value exploratory testing over confirmatory testing. That would be way, way, way too simple, okay? All I want to say is it's not just about the one, and it's not just about the other. It's about both at the same time, guys. And so we regard something as thoroughly tested when it has been checked by efficient, formal, confirmatory test automation. Of course, based on a solid test case design, and when it has been explored by the richness of intellect of human beings, by you guys. Now, that's at least our agile equation of motion, and the reason why we pay so much attention to exploratory testing in all of our testing projects. Okay, guys, now we have seen quite a lot. We have scratched the surface of API testing, of orchestrated service virtualization. We've talked about the necessity of risk-based testing, especially in enterprise environments. And we have talked about the importance of exploratory testing. But now let's see if all those techniques or approaches really make an impact. Because if they do not make an impact, then their absence does not make a difference. Now let's see if they really make a difference. And let me show you that based on a customer project we started 2 years ago already. And this project was in the banking sector. It was all about securities trading. That means trading of financial instruments, such as shares, bonds, funds, for example, or even metals. Now, the initial condition of the project was that all of testing was in manual testing, which simply means that there was not a single automated test case in their regression test portfolio, okay? In that project, about 11 manual testers were around. And those 11 testers, by manual testers, by the way, I mean they didn't have the appropriate skills to build a test automation framework, okay? So those 11 manual testers, they had to execute and to maintain about 5,000 end-to-end regression test cases scattered across more than 12 different technologies and platforms. And it took those 11 testers about 10 weeks to just execute that regression test set. And at the same time, they had no idea about the risk coverage. Now, the interesting story about this example is that the goal of this company was to be able to ship a potentially shippable product within a single week. So it's a huge challenge. And they didn't really know what to do, and I'm not joking, this was our project charter. That's all they gave us. They just said, Ingo, there's a way to do it better, find it. Of course, we accepted the challenge. And now let me guide you through step by step what we did in order to transform that traditional approach to testing for, let's say, great agility. Now, the first thing we did is we captured, we structured, and most importantly, we prioritized all the requirements that were part of the game on the level of user stories, on the level of epics, on the level of themes, for example. And then we took those 5,000 end-to-end regression test cases and mapped them onto these risk-weighted requirement structures. Now, in order to make the risk coverage visible, so it's the first improvement, right? So it turned out 40%. And then you might say, well, that's actually bad, right? 40%, that's pretty low. But it isn't, because all those test cases were created completely intuitively. So they didn't really have a structured and methodical approach to test case definition at hand, which we call test case design. So that is what we did in the first 2 days. And in the next 2 weeks, the next steps were obvious. We applied test case design, and we paired it with risk-based testing. Now, here we achieved 2 improvements. The first one was we reduced the number of test cases by a factor of 4, and we increased the risk coverage close to 90%. And there was no black magic involved in here, okay? So we have seen here 3 things happening. The first one is we've seen so many high-priority requirements that were completely under-tested or untested at all. And by high-priority requirements, I just mean those requirements that contribute most to the overall business risk, according to the model we created, okay? The second observation was we've seen so many low-priority requirements that were completely over-tested. Hundreds of test cases assigned to those low-priority requirements. And it really turned out that these people loved, to automate login pages or stuff like that. And in addition to that, we also seen that the redundancy level in the test case portfolio was dramatically high, close to 75%. And this is not a one-time observation we make. We make this observation almost every time we arrive at our customers. Now, with all that, guys, we managed to reduce the execution time down to 5 weeks. And then we obviously had a problem, right? Because the number of test cases was reduced by a factor of 4. Execution time just went down by a factor of 2. Of course, we redesigned and created new test cases. So this would have implied that the test cases we redesigned now take twice as long to execute, right? And it simply says we just messed it up. And we didn't really believe it, right? So we analyzed that for 1 day, for 2 days, and for 3 days, and we didn't find the root cause. And after those 3 days, those guys came to me and told me, Ingo, honestly, we've never been able to execute all of those 5,000 test cases in 10 weeks. We just managed to do about 50% of that in 10 weeks. So the actual regression test time, guys, was between 17 and 20 weeks. So that's huge. Now, after that, we also applied a synthetic approach to test data management. We are still in manual test execution here, okay? So what it means is we were able to synthetically create all the business objects that were part of the game. A business object is, for example, a customer or a cash account or the custody account of that cash account of a certain customer in their banking application. Or financial instruments and all those transactions that these things were created synthetically. And we managed to do that for about 85% of the business objects. The rest was then supplied with masked production data. And just by doing that, execution time went again down to 2.5 weeks. And this then implies that those guys have spent 50% of their valuable testing time during manual test execution just to find the right test data during manual test case execution. And this is just ridiculous, right? Now, after that, we then moved on to test automation. Why? Because now we have established a solid basis for test automation. Now, we have applied then our model-based test automation approach in Tricentis Tosca. That's the tool we are using. If you want to see it in action, please come to our booths. So what we have achieved was we reached an automation level in absolute terms of 90%. And 2/3 of all those test cases were based on APIs or driven by APIs. In order to scale your test execution to almost any arbitrary level. So execution time went then down to 48 hours on a single machine. And then our job was basically done. We then also distributed all of those automated test cases across, I think, 6 machines in their test labs and virtual machines in order to reduce execution time again down to 8 hours. And then we also extracted a smoke test portfolio. That means what we did is we searched for the most important 7% of the test cases. And again, by most important, I just mean those test cases that contribute most to the business risk. And we were able to do that because we didn't just apply risk-based testing on requirements level, we also applied it on test case level. And with those small set of test cases, we were able to cover about 50, or to mitigate about 50% of the business risk in about 30 minutes on an end-to-end level, okay? So 30 minutes to 1 hour. And then we took those smoke test portfolio and we embedded that into our CI and CD pipeline, okay? And so this smoke test portfolio was then executed multiple times a day on demand, you know, whenever a developer checks something in and requests a build, and in periodic time intervals, for example, in nightly builds. And that is how you then eventually enable continuous testing, right? You do then testing in an uninterrupted way from an automation perspective. But guys, the best result we achieved in that project was this one here. We managed to reduce the number of critical defects in production by more than 70%. And we measured that over 1 complete year and compared the results, you know, to the average of the previous years. And it's hard to pinpoint to any specific technique and say, well, what really caused that? But according to my gut feeling, the main contributing factor was a structured approach to exploratory testing. Because the bottom line here was that the testers, again, learned how to test and not just how to automate, guys. And it's not a big deal to achieve all that. So I don't want to say how cool we are and how great things we achieved. I just want to say it's not a big deal to achieve all that. This took us 3 months, roughly 3 months, with just 2 persons, okay? 2 persons without any comprehensive test automation skills. And so with that, guys, I also kindly ask you to move out and to transform your traditional approaches of testing for a great agility. And do it now, because the future doesn't just happen, it gets happen, guys, so make it happen. Thank you so much.